Thank you for joining our session today. So this session is about the deep dive into DDoS attacks and metrics. I'll be focusing on how to use real-world data and tools to detect, analyze, and ultimately protect against polymetric DDoS threats, targeting both your network and also application layers on Azure. So before starting, let's have a quick overview of what I will cover today. So we will start by looking at the Azure, by the DDoS attacks trends from Microsoft latest reports, and I'll walk you through the core capabilities of Azure DDoS protection. Then we will shift the focus to Azure WAF, covering common attacks types and also how WAF plays a key role at the application layer. After that, I'll show you a live demo covering both layer 3 and 4 and layer 7 attack scenarios. So how to investigate using logs, metrics that we have, and how to detect abnormal patterns using the KQL queries that we have, and help you use them in the real world scenarios. And then at the end, I will also wrap up by looking at some how to use the rate limiting strategies for application for the WAF for mitigating volumetric attacks at that layer. Okay, so before going into the detection mitigation, let's first have a look at like the DDoS attacks. So what are DDoS attacks? DDoS attacks are when there is a huge amount of traffic or the specific type of traffic that brings down or degrades your network or application's availability. There are a lot of different types of DDoS attacks that I will show you later, and also which is the best practices and how to mitigate them. So looking at the DDoS landscape today, according to Microsoft's security report published last year, there was a noticeable shift in the attacker behavior. So between March and June 2024, Azure recorded an average of over 4,500 DDoS attacks per day. That's a massive volume of traffic. And while a lot of it was still network layer attack, the most impactful incidents increasingly targeted the application layer. So these application layer attacks are different from the typical floods that we usually see. Instead of overwhelming your infrastructure with raw volume, they target specific endpoints like login portals, check-in systems, or payment pages. So using these requests that look completely legitimate, from the outside, it appears like a normal user traffic, but at scale, it can take down a service. And one tactic that stood out was the rise of loop attacks. Those exploits protocols like DNS or legacy UDP services to create self-sustaining request loops. They don't need amplification. They just create enough noise to overwhelm your backend. And we also saw some regional spikes. And for example, in India, attack volumes more than doubled, especially in industries like gaming. And what all of this tells us is that DDoS is evolving fast, not just in scale, but also in sophistication. So now let's start with the types of DDoS attacks that we see. The first one is the volumetric attacks. So these attacks aim to overwhelm the target by flooding it with an enormous volume of traffic, enough to saturate the available bandwidth and makes the system unreachable. They're relatively easy for attackers to generate, often using amplification techniques like with protocols like DNS or NTP to multiply the traffic. And usually the result is that there's so much noise that legitimate users can't get through. So volumetric attacks usually are measured in bits per second or packets per second, PPS, and their goal is simple: exhaust network capacity. And this is where Azure DDoS protection comes in. It's designed specifically to detect and automatically mitigate these high volume of floods before they reach your resources. Now, for the second category, which is the protocol attacks, and they're also known as state exhaustion attacks. These they don't aim to saturate bandwidth like the previous volumetric attacks. Instead, they try to exhaust the processing capacity of your infrastructure, whether that's your web browsers, web servers, load balancers, or even firewalls. So they work by exploiting weakness in the network or and the transport layer protocols. So things like IP, ICMP, IPsec, or TCP and UDP. A classic example is the TCP sync flood. In this type of attack, the attacker sends a flood of TCP sync packets to initiate the connections, but never completes the handshake. So what happens is that the victim system tries to respond to each one of these requests and holds the connection open, waiting for the final act that never arrives. And that's how it uses up all the resources, for example, for a web server. So all of these have open connections built up. The system resources are consumed until the server can no longer accept new legitimate requests in that case. So for the third category or third type, the resource exhaustion attacks, also known as application layer attacks. So unlike the previous categories, these attacks, they don't target the network or transport layers. Instead, they aim to exhaust the resources of the application itself by exploiting how the app handles incoming requests. And the typical example is flooding a web server with what looks like legitimate HTTP requests. So while each request is easy to generate, responding to it often requires the server to load files, run databases queries, or make external API calls. So that adds up quickly on the backend, even if the traffic volume isn't particularly high. What makes these attacks so challenging is how authentic they appear. So the traffic blends in with real user activity, making it hard to distinguish a DDoS attack from a surge in normal usage. It's also important to call out and to mention here that Azure DDoS protection doesn't currently mitigate this category. However, that's where the Azure WAF comes in, and I will also provide more details later on how to mitigate these type of attacks. Now, let's take a moment to review the Azure DDoS protection and what it actually offers. So at its core, this is a cloud scale service that provides any Azure resource running inside virtual network, so your public IPs in a VNet. It leverages the power of Microsoft's global backbone, which means the protection is applied at the edge before the traffic even reaches your workloads. One of the key strengths of the service is the adaptive tuning. It learns from the traffic patterns and automatically adjusts mitigation thresholds to match your baseline. So to get an accurate protection without needing to fine tune everything manually yourself. Once an attack is detected and mitigated, you get also rich analytics and metrics that can help you to understand what happened, volume, duration, vectors, and also how mitigation kicked in. And I'll show you more information on this in the demo. The Azure DDoS protection also integrates natively with Microsoft Defender for Cloud and Microsoft Sentinel, so you can correlate attack data with broader security events that you have there. You can also build automated workflows or alerting for that. For more critical incidents, there is also the rapid response team, which is a 24-hour, 7 days expert support that can assist you during active attacks. And finally, there is the financial SLA and cost protection included, right? So that means that if you're attacked and you're scaling out to absorb the impact, Microsoft will cover those additional resource costs, giving you both technical and also financial resilience. Currently, we have two SKUs. So there is the Azure DDoS Network protection SKU, and then the IP protection SKU. In terms of mitigation capabilities, they are both similar or the same. What's the main difference is the pricing structure, where you enable DDoS network protection on your whole VNet, while the IP protection can be enabled on a few specific public IPs you have. And then there is some added support like the rapid response support and cost protection that is only available for the network protection. So now let's jump to the Azure WAF, the web application firewall. And again, right, let's go into different types of web application attacks first. It's important to understand, like, the types of attacks it's designed to stop. And these aren't just like, the high volume floods. I'll also mention the subtle, more hard to detect. So the first category is the application layer DDoS attacks. So these aim to overwhelm your app using, high volume of HTTP, HTTPS. And the attacker can send like thousands of GET requests per second to overwhelm your system. And this is where the WAF comes in. You can enable, for example, rate limiting to stop these type of attacks. The second type is web application exploits. So these attacks go after specific vulnerabilities in your code or backend logic, like SQL injection, cross-site scripting, or command injection. They can steal data, hijack sessions, or even gain full access to your systems. So these are exactly the type of threats that you can protect against using the OWASP aligned rules that are available in WAF. And finally, we have the malicious bots. These are automated tools that scan for weaknesses, and they scrape content and also abuse your login pages with credential stuffing. So some bots they can even launch denial of service attacks, like DDoS attacks. And WAF includes also bot protection to protect against these type of attacks. So now with these threat types in mind, let's have a quick look at Azure WAF, how it works, and some of the capabilities it has. So Azure WAF is a cloud-native platform managed security service that protects your web applications from common threats and vulnerabilities. Because it's platform managed, Microsoft takes care of the infrastructure, updates, and scaling. That means no patching and also no manual tuning of the infrastructure itself. So just focus on your app while WAF adapts to the traffic demand. It's also designed for high availability and performance at scale. So whatever you're protecting a single regional service or a global distributed platform, WAF can scale with you, while also keeping the latency low and the uptime high. Another key benefit is the WAF can protect apps also hosted like inside Azure or outside of it, so in hybrid or multi-cloud setups. So it's not just for Azure native workloads. It's powered by Microsoft Threat Intelligence, so it's constantly evolving to respond to new attack vectors, including zero-day threats and also meeting compliance standards that are needed in sectors like finance, healthcare, or public services. Now, when it comes to the deployment, the WAF integrates at two layers. First is globally with Azure Front Door. And this is where it filters traffic at the edge, so closer to the source of attack, across hundreds of Microsoft Edge locations. And regionally, with Application Gateway, which is a web traffic load balancer running inside your virtual network. So this gives you more localized control and visibility, especially when you're operating entirely within a single region or if you need like tighter VNet integration. So both options use the same WAF engine, but the deployment model gives you more flexibility depending on your architecture and performance needs. The Azure WAF also comes with rich set of features that are designed to provide you with intelligent, adaptable protection for your web applications. Some of them, so the first one is WAF includes pre-configured managed rules based on OWASP Top 10, and this can give you immediate protection against threats like SQL injection, remote file inclusion, without requiring any custom tuning. Then we have the bot protection. So WAF integrates with Microsoft Global Threat Intelligence feed. That means it can recognize and block known malicious bots in real time and preventing different type of attacks from bots. And one of the more powerful capabilities is the conditional rate limiting, especially when used with Azure Front Door. So this lets you throttle requests from abusive IPs or regions, which is crucial for defending against layer 7 DDoS attacks, where the traffic volume looks legitimate. Then we have the custom rules engine, which gives you a complete flexibility to define your own logic. You can write rules based on IPs, request headers, cookies, URIs, or even query strings. Within the custom rules, you can also configure geofiltering to allow or block some specific traffic that's based on the country or region, which is also good for compliance and reducing exposure from high-risk geographies. And you can also apply IP restrictions, enforce HTTP parameters rules, and set size limits on requests, so helping also detect abuse or reduce the attack surface. On the monitoring side, WAF offers detailed logs, metrics, which are very important for tuning your policies and investigating suspicious activity. And finally, the Azure WAF integrates natively with also with Microsoft Sentinel and other SIEM platforms, so you can trigger alerts, investigate incidents, and even build automated playbooks for real-time threat response. So with all of this, now for the next stage, I will show you a demo of how you can use this. So I'm going to stop sharing my slides, and I'm going to go over to my web browser where I have the Azure portal open. Okay. So first, I'm going to start with the layer 3 and layer 4 DDoS attacks, logging metrics. So I'm going to focus on Azure DDoS protection. So the first thing I want to show you is the Azure DDoS protection itself. So I'm going to click here on the DDoS plans to view the DDoS protection plans that we have. And you can see here that we have, for example, 2. And if I click on this one, you can see here under protected resources, I have the VNets and then also the specific resources where the public IP is attached. The important thing that I want to show you specifically, and that's regarding the logging here, right? So I'm going to go to application gateway for this example. And under application gateway, I have this one public IP that I'm protecting. So I'm going to go to this specific public IP. An important thing to know is that even when you have the Azure DDoS protection enabled on this public IP, and you can confirm also if you click down here on the protect, it will show you if it's protected or not. And you can see that this is protected. The important thing is to enable the logging. So when you enable DDoS protection, it doesn't automatically enable logging. So important thing is to come here and make sure you have at least one diagnostic settings enabled. And as you can see, I have one here configured that is sending the logs. So I'm gonna edit settings just to show you how it looks like. And you can see here that we have 3 categories, and I will show you each one what they mean. And I'm sending all of these to my log analytics workspace, which is called in this case CyberSOC. So what happens is that when there is a DDoS attack, all the logs are sent to my log analytic workspace. So now I will show you how you can check these logs and how you can do also some investigations. So I'm going to jump here to my log analytics workspace, and I'm going to start some queries over here. So I'm going to start with basic queries, and the 3 categories that I mentioned earlier for DDoS are here. And you can see that the first one is DDoS protection notification. So this category, you will get only 2 logs for this category when there is a DDoS mitigation. Basically, one for when the DDoS attack starts, and one when the mitigation finishes, right? So the DDoS mitigation, and there is no more there is no more DDoS attack happening. So when I run this query, the DDoS notifications, and you will see here how the results and how they look like. This will help you understand, for example, if you were under any DDoS attacks, and then when you open them, you can see also the details for this. So for example, this log is the mitigation stopped. So it tells you that the mitigation for this public IP that I have stopped because it's the traffic is below threshold. So this is very useful, especially when you want to set some alerts, and especially for the DDoS when it started. So I'm gonna go back here for example to this one, and okay, let me try this one to try to find one. Okay, so this is mitigation started, the one I'm looking for. And basically what you can do, you can set an alert based on this log. So when a DDoS attack starts, you will get an alert, and you can have that alert send you an SMS, email, or start a workflow that you're using. So this is the first category that's very useful. The second one that I want to show you is the DDoS mitigation flow log. So this one, I would say to definitely be careful of enabling this one if you have too many, a lot of IPs and a lot of traffic, because this will generate a huge amount of traffic. This will log a sampled version of all like the traffic when there is an active DDoS attack, right? So I'm gonna run this one, and you will see now that there will be a huge amount of logs here. And you can see that there's it showed the limit, which is 1,000 I have set here. But in general, this will generate a lot of logs, because this, if I open it, each log here will show you each, like for example, the packet that went through, and it will show you the information like source IP, port, destination, and so on, and also the result, right? So for this one, protocol violation, invalid TCP sync, right? So this one tells us that this packet was dropped because we're in the mitigation pipeline. When it was checked if it was a valid TCP sync, there was no reply. So we knew that this was an attack of TCP sync flood, and this packet, for example, was dropped. So, and I will show you, like, if you look at this, there's so many logs here that it's hard to, like, it's not very useful to go over each one of them. And I'll show you in a bit in a workbook how you can aggregate this and get some useful insights. Now, to the next category we have here, that's the DDoS mitigation reports. So this category, it will generate a log every 5 minutes during an active DDoS mitigation, and then one last log at the end of the DDoS mitigation, which summarizes all the mitigation that happened. So I'm going to run this one, and you will start seeing logs here. And what I want to show you here, so let me go a bit to the right side over here, try to find it. You will see here information like, about the attack. So let me go back and let me try the other way. So let me open this log. Okay, so what you will see here, the report type, for example, is incremental. So this is one of those incremental logs that we have that are every 5 minutes. And down here, you'll find useful information like how many traffic there was, like total traffic, and you can see 900 TCP packets, type of protocol, drop reasons, and all of that. Now, one of these, you will find that it will be show you report type as the final one, the DDoS report, and that one will have all the information mentioned here. And again, right, this is useful, but when going over this, it's a bit difficult to make any reports based on this information, and that's why I'll show you now how to use our workbook, which aggregates this information and makes it a lot easier to investigate and also to get more insights. But before doing that, actually, I'm going to show you a few more queries that will be very useful to you. And these can be also used when you're investigating. So these logs are available in our GitHub. If you want to use them, you can also find them there. So the first one that I want to show you is this one. So this one will look at the post-mitigation report type. So this is the one I mentioned for this category, which is after the mitigation finishes. And what I'm doing here, I'm looking at the like to get a sense of the trend of the total packets and how many also were dropped for each public IP to get a like understanding of the size of attack and also what happened during the attack. So I'm gonna run this, and I'm gonna first actually go here to the results, and you will see here so that we understand that we had 3 mitigations basically. This is the public IP that was targeted. So this is the public IP that was targeted during this DDoS attack. And you will have information here about when the mitigation started. And you can see also, for example, here, total packets, how many there were, and how many were dropped. Now, what you will notice are that they're pretty similar, and the reason for that is because there's not so much traffic going through this public IP, and like most of the traffic came from the DDoS attack itself. But as you can see, most of them were found and most of them were mitigated. And here you can compare and you can see how many, what's the total number of packets, how many were dropped, and also when the mitigation started and which IP was affected. Now, another useful query that you can use is to see the DDoS mitigation duration and also the attack vectors. And you can use this query that I have here, that I'm using also the post-mitigation reports. And you will see again, right? So we know that we have 3 attacks in this specific time range. And you will see that, these are the public IP addresses. You will see here information about when it started, when the mitigation ended. So you can see the duration of the attack. And then here you will get the duration in minutes. So you can see specific how long was the DDoS attack. And over here, you can see also the attack vectors that were seen during this attack. So this will give you a good idea of the timeline for those DDoS attacks, duration, and which public IP address was targeted. And again, right, the Azure DDoS protection doesn't need any specific manual tuning from your side. It's auto-tuned using based on the traffic and thresholds, so it's all done automatically. But you can use this information to then gather more insights and do also post-mitigation investigation. So these are very useful queries that you can use. Now let me show you the workbook, which I think will be also very useful for reporting. So let me go over here. And over here, you will see that I have the Azure DDoS Protection Workbook opened. And this workbook you can also use. You will find it in our GitHub. You'll find it also in the public documentation for DDoS protection. So what I'm doing here, right, in this workbook, first thing here, I have selected the workspace. So this is where I'm looking at the logs from which workspace. I have a specific time range, so I'm looking at last 28 days, and I have all the public IP selected, right? So if you're doing investigation on some specific IPs or section, then you can also change it over here. Now it will, as you can see, the first thing it will give us traffic overview, so it will give us the total amount of packets, how many were dropped, the protocol, and so on. Here on the left side, you will have all the mitigations over here timelined differently. So if you want also to investigate a specific DDoS attack, you can click on it and then see that only information for that. And here on the right, you can see also some information about like the resource connected to this specific attack. And let me show you how it works actually. So I'm going to click on this last attack that we saw. And you can see that this is related to our Azure Firewall, right? So we know that the public IP is on the Azure Firewall, and Azure Firewall was attacked in this case. So I'm going to clear this for now, and I'm going to scroll down. As you can see here, this is not clear because I'm zoomed in, but I'm going to zoom out for just a second to show you how it looks like, just to give you an idea. So this is how it should look like in general. I know the numbers are very small, but you will have here an idea of the percentage of, for example, the protocols, the continent of origin, where the attacks come from, the countries of origin, AS numbers, and also the drop reasons, right? So you'll get an idea of where most of the attacks come from, which protocol they use, and so on. Let me zoom in again here so you can see what's showing on the screen. Okay, so let me scroll down here, and again here, right, this is similar information just shown differently. And then down here, you'll find like raw DDoS mitigation logs, similar to what I showed you earlier, just here I have it selected for all the public IPs. And here are the flow logs. So I'm gonna go back up here. And so this is the first page, which is the summary. Now on the second page, DDoS metrics here. And I'm going to scroll down again here. So this is also a very useful page. It will show you, for example, here, all the public IPs I have selected, and it will show you over the time what's the packet count or the average packet count that you see for them. So you can see some any like specific trends, anything that looks abnormal, or DDoS attacks. Like here, clearly you can see that this public IP was under a DDoS attack with this huge surge of traffic. On the right side, you can see also, like, for example, the byte count here. Then down here, these are more of a DDoS metrics. And what I mean by that is that these are only shown when there's a active DDoS attack and a mitigation. And on the left here, you can see like the inbound sync packets to trigger DDoS. This is actually the specific threshold that we have for our public IP. So only public IPs that have DDoS protection enabled, and you can see that they are different because the threshold is based on the traffic and the attached resource scaling where the public IP is attached. So they will have different thresholds based on the policy, the auto-tuning that's being done, and you can see here different thresholds for that, right? And here on the right, you can see when there was a active DDoS attack and for which public IP, right? So you can see here one means that it was under a DDoS attack. So these are metrics for Azure DDoS protection aggregated for multiple IPs. Now, on the last page here, I will show you the DDoS investigation. Give me just a second. It's loading. Okay, let me try again here. Okay, awesome. Sorry for that. So here we can see some information where we can do also investigation. And here we have the, for example, allowed traffic during mitigation. So you can see like, what's the traffic usually that's allowed. So legitimate traffic that we see during a mitigation. And on the right side here, we will see the dropped traffic during mitigation. So down here, we can see also the top attacking IPs. And the top attacking IPs, we will get an idea where the attack is coming from. So which IPs are we see as malicious IPs during these attacks. Give me just 1 second. I'm having a bit of problems here with my mouse. Give me just 1 second. Sorry. Okay, sorry about that. So continuing, going down here, what you'll see here on the left side is the DDoS mitigation activity. And here you can see, like, for example, that migration started and migration stopped for which IPs. And here are all the attacked IP addresses, right? So you remember they were showing 3 attacks and 2 different IPs. So these are the 2 IPs that were attacked. If we want to see also like more information about logs related to these IPs, we can click, for example, on the specific IP, like I did here. And on the right here, it will show you the table matches related to it. So I'm going to click on the Azure Diagnostics. And then down here, it should start generating the logs for this Azure Diagnostics. So just 1 second. Okay, awesome. So these are the related logs to this public IP, and you can also do like more investigation and have a look at what's happening here related to this public IP and the attached resource. So this is the workbook, and this is how you can investigate. You can also get insights in the DDoS attacks at layer 3 and 4, right? Now, I want to show you also, so this is not all types of DDoS attacks, right? There are also as I mentioned earlier, application layer DDoS attacks, and I will show you now how to protect against them, and that's using the Azure WAF that we have. So I'm going to jump over here, and for this example, I'm going to be using the Azure front door, but more or less it's very similar to application gateway WAF also. So this is the front door WAF policy I have open here. And if I go over here to custom rules, that's the one that is interesting for us today. And to protect against volumetric layer 7 DDoS attacks, you'll have to set rate limiting rule, right? So you'll go over here and you will have, like, for example, a rate limit. Let's call it just 4. Let's call it like this. Okay, that works. Doesn't like spaces. So we have the rate limit rule name. Now the rule type will be rate limit in this case, right? We will give it a specific policy, and we can say, like, this is the first thing that we want to check. So we can give it like priority of 5, and then you can select here the rate limit duration. Let's say 5 minutes, and the rate limit threshold. So when you get to this part, right, the rate limit threshold, and now you have to select the threshold for your rule, right? It's usually a bit difficult to know what's the right threshold to choose, right? So in this case, I have the rate limit duration set for 5 minutes. Now, the reason I choose 5 minutes for this rate limit is because for AFD WAF, it's recommended to use 5 minutes since there are different edge locations for because it's CDN, and these edge locations have different counters. So sometimes if you select 1 minute, there can be some delay between the communication, right? So the recommended for AFD WAF policy, usually it's 5 minutes. That's the one that is more accurate. And the logic, like, at least here right now, the way I have it is that in this specific time window, so in this 5 minute, the rate limit threshold is 100 requests. And for example, down here, I can go and I can choose, like, I don't want to select some specific IP address, but let's say that, I'm gonna, like, select, like, all of them, right? So it doesn't matter, like, which like, specific IP I want to, all of them to have like this rate limit rule. What happens is that for each public for each IP, if it reaches, or if it sends more than 100 packet in this 5 minute, then it gets denied. As you can see here, I have denied traffic. It will get denied and it will get dropped, right? So this is the logic of the rate limit rule. But again, it's difficult to understand how to get the information on what settings to set here, right? So I'm going to show you a bit how to use some queries and how to get a better idea of your workload baseline, like the traffic that is going through it, and help you set the the correct rate limit threshold, and also the different techniques that you can use here. So I'm going to go back here first to the logs here, right? So I'm going to jump here to AFD. So I'm going to look at these queries. And the first thing that we want to do in this case, let's say that we want to set a rate limit rule for all IPs, right? So this is like the baseline rate limit we want to set at the WAF. And we were, let's say, under a DDoS attack, and we want to set a specific rate limit rule so that doesn't happen again. So the first thing that you can do, you can use this query, for example, and this one calculates the average number of requests per client IP, and it's in 5 minute intervals. Now, this is important, right? Because the reason also we're looking at 5 minute intervals is that so that we can compare this results from this investigation to the rate limit we want to set here, right? So we are going to use 5 minutes here, the rate limit duration. So we're going to also, base the data, use 5 minute interval to understand what's the baseline. So again, this is in a time interval of 5 minutes. It's per client IP, and the client IP is the same logic again here, rate limit. So this is also per client IP, right? and it will look for the average number of requests, just so we can get some idea. So I'm going to run this query, and let's see what we get. Okay. So as you can see here, these are all 5-minute intervals, and you can see that it will show us. So I have it also sorted by the highest, just to have an idea what's the highest, like amount of average request per IP. And you can see here that during this time it was 1066. Now the important thing when doing this exercise is to view this in a time range where you had an active DDoS attack. So let's say that there was a DDoS attack between here Friday and Saturday. What you will do, you will set the time range for this specific date, and then you will view the top average request per IP here, and you will find that the top ones are a lot more higher than the others, right? And once you do that, then you will do this again, but you will choose a time range of a typical day, right? So typical traffic that you see, so you can see the trend. And what you will see then there, you can compare the normal number of average requests per IP and have a specific threshold. Now let's just assume and say that this was during an attack, and I can see that these are like abnormal, and for example I see that 800 is what I see normally. But usually when when you do this in your environment in a work, like in production, you will see huge amount of IP traffic here, and there's a big difference between when there is an active attack, so you will get a better idea. But let's assume we want to set this here, right? So let's say that 800 we can see here, like it's the top 1% here, and then everything most normal traffic is all less, right? So in the usual 5-minute interval, there for each public IP there is usually less. So this is pretty useful, but again, this is the average, right? So this is it can help us. We have now an idea. Let's say it's 800. So now for the next query, what I'm gonna do here, I'm gonna run this query which will find the maximum request seen from each client IP in any 5-minute interval. So let me run this here. And give me just 1 second. Let me just change the audio over here. Okay. So this is another query that I will show you now here. And for this one, now we're looking at the maximum request, right? So we got an idea of the average. Now we want the maximum. And this is per public IP or the IP, and not using the specific 5-minute, the interval, right? So we're looking at the public IP, and this is also in 5-minute interval, but aggregated to only IPs. So this will give us another idea of what is the normal max request per IP, 5-minute interval for a specific IP. And what we see here, let's say in this case, we said earlier it's 800, right? So we can see that we will see top IPs with huge amount of max request per IP suddenly initiating attacks. And understanding that difference, what you can set then is the baseline. And again, this exercise, this query, you should do it when there is when there was a DDoS attack on your environment, and again when there is just normal traffic, right? So you can see the difference. But if there was if you don't have any information on a DDoS attack, then you can just simply look at your normal traffic. For example, normal traffic is the top is 800. Then you can set the rate limit for 1000, because that usually there will be no IPs going over that. So this gives you a good insight and information on what's the baseline for the traffic going to your workloads on a normal day. This can of course change also if there are some specific events, so keep that in mind. And using this information, then you can go back to your rate limit rule and set some specific rate limit that you want. However, again, right, this, there could be some edge cases where some legitimate traffic that goes over this threshold. And, you don't want any legitimate traffic being dropped, right? And this is where the custom rule engine is very powerful and useful. What you can do is that, let's say that we set here 1000, and I want to be careful so that even if there are requests going over this 1005 minutes, it doesn't just deny them if they're legitimate. What I can do is I can set, instead of deny traffic, I can select, for example, JS challenge here. What happens is that if, and looking at the logs, right, that's like 0.1% of traffic that goes over this limit, they will still not be directly or just denied, but they will get a challenge, the JavaScript challenge. And if they are not a bot, if they are a user, and usually these attacks come from bots where they're generating this type of attacks, then they will succeed the JS challenge. Let's say like not the normal user, and they will still have access to your workloads that you have, like web service. So what happens here is that only legitimate traffic still goes through, even if it's over this rate limit. And you want to be very careful, so you don't have to set it at deny, but JS challenge in this case. So this is one way and technique that you can set, rate limit for, baseline for all, like, pure for all IPs that are going there. But you have to be, again, very careful with this and do, like, the necessary research to understand your baseline. Now, another technique that you can use is, or another rate limit technique that you can use is looking at, also like, for each country, so specific geography, right? So I'm going to run this query. So for each country, it will show, a 5-minute window, it will return the most active client areas. And basically, I want to look at the countries. So I'm going to just do, actually, you know what? Let's go for request count, and let's look at the highest, like, requests coming from countries. And you can see that, for us, it's, for example, maybe United States, right? So what you can do again here, right? You can look at, normal time range for, your traffic, and you can see that where your, normal users are coming from, and understand, like, the normal user base. And you can do this exercise in this query again when during an active attack, and then you'll get an idea when you see like some spikes from countries that, where the attack is coming from, and you don't see normal users, right? So using that, and let's say, like, in this case, I'm going to go down here. I'm just going to give you an example. And let's say it's, let's choose Hong Kong because we have just United States otherwise. And we see, like, huge amount of traffic, like request count here, 5 minutes coming from Hong Kong. And we can see like it's, 10,000, something like that. And it's a lot more than usual. What you can do then is you can go back here to the this rate limit rule, and you don't have to replace this, with the one you have already, right? So you can see you can also set another one called jail. And for this one, what we will do, we will match type geolocation. We go here specifically and look for, Hong Kong, right? So you can select it, and we know then we don't want to, we don't want just to deny all of, traffic from Hong Kong, because there is some legitimate also traffic coming from there, but we don't expect that much traffic. Let's say, we don't see it usually. You can set like, something like 800 for, depending on the query that we see, and selecting the countries that you don't usually like, see based also on the information, and set this rate limit. And in this case, we can do JS challenge, or we can just do deny, and then you can add it. So this is another layer that you can implement, and this will very depend on your workload, where your customers are coming from, and the type of traffic. Now, the last one that I want to show you is using the URI. And so the first one I'm going to run is this one. This one will also show us, the URI across 5-minute interval, and will show us the highest usage. So it will show us, based on the URL that users are accessing. But as you can see, this is not super useful because, it doesn't give us that much useful information. There's so many, different types, different URLs here at the end.
So what we can do actually is to use this query, which shows us, aggregated by the first path. And what you will see here, for example, so I'm gonna just also change the request count, and you can see that, for example, the URL that is being used. And where it's useful, this query, is when you look at the chart. So I'm gonna open a chart here, and here you'll get an idea of the different, URLs you have here, and also where most of the customers are hitting, right? So using this information, right, again, going to the customer here, you can set a specific logic for it, right? So you can, have this specific URI, so request URI, and you can have for example, you can set here, login page, something like that, and then you can set the specific rate limit, because attackers sometimes they will hit the specific pages that they are aware of, and you can set also specific rate limiting for those, only for those URLs, so that they don't get hit, and you can specifically protect your workloads from that type of traffic. So this is another technique, rate limiting, and again, right, you can stack these different custom rules, to improve your posture and improve, the protection you have against different DDoS attacks. Okay, so this is the last one I wanted to show you. Again, right, I showed you how to investigate, get insights for layer 3 and 4 using Azure DDoS protection, and on Azure Web also how to use, these queries to get some baseline information, and then use that information to configure your rate limit. But one more thing, right? There's a rate limiting, but don't forget that we also have, for example, bot protection rules, which are also very useful against DDoS attacks, because once we know that, there is some specific, let's say, bots that are initiating DDoS attacks, they will be added, like, for example, this one, and you can choose then the action to deny, or, a different action for them. So keep this in mind, and, make sure to use all the tools that are available. Okay, so with this, I'm gonna jump back here to the slides, and let's see if there are any questions, because I think we're almost finished, out of time.
Thanks so much, Saleem. Yeah, it looks like our Q&A team has answered all of our questions in the chat for us. So I think we are good to wrap up. So I just wanted to say again, thank you so much, Saleem, for being our guest today and for sharing all of the great information with our community. Also, thank you to the Q&A team who helped us with answering all of those questions and providing the resourceful information. To all the listeners still on the line, if you are someone who wishes to aid in the protection of the world from cyber threats and desire to have a say in shaping our strategies, blueprints, and recommendations, then we invite you to become part of our security community. Together, we can make a global impact. So join us at aka.ms/securitycommunity. This is also where you'll be notified about the upcoming webinars, events, and other announcements. For those of you who may have additional questions on the topic we just covered or other product-related questions, please feel free to raise them on our Microsoft Tech community discussion space at aka.ms/anscommunity. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.